In last class, we have discussed regarding root locus problem, right? Today, this question paper is 17 scheme and control system subject. This question paper asked in February, March 2022. Okay. The question is like this: explain the following as applied to the root locus, centroid, asymptotes, breakaway points, angle of departure. Right. First, we shall see the formulas of that. Okay. So first, centroid. Find the centroid and the angle of asymptotes. If P equals to Z, then all the root locus branches start at finite open loop poles and end at finite open loop zeros. Okay. Before going to the particular topic, we should discuss rules for construction of root locus from starting itself. Okay. First, what we do, rule 1, locate the open loop poles and zeros in the S plane. Next, rule 2, find the number of root locus branches. So, we will find the n number of branches and the starting point and the terminating point we will find. Okay. And next, identify and draw the real axis root locus branches. So where root locus branch exists, okay, where that is if odd number of the open loop poles and zeros exist to the left side of a point on the real axis, then that point is on the that point is on the root locus branch. Therefore, the branch of points which satisfies this condition is the real axis of the root locus branch. Okay. And if the angle of open loop transfer function at a point is an odd multiple of 180 degree, then that point is on the root locus. Next is a rule for find the centroid and the angle of asymptotes. So we shall go to the that is directly centroid. Asymptotes give the direction of these root locus branches. So asymptotes give the direction of these root locus branches. And the intersection point of asymptotes on the real axis is known as centroid. The intersection point of asymptotes on the real axis is known as what? Centroid. So what is the formula for asymptote? First, asymptote's formula is theta equals to 2q plus 1 into 180 degree divided by p minus z. P is a pole, z is a zeros. Always poles will be in the denominator and zeros will be in the numerator. Next, centroid formula is alpha equals to summation of real part of a finite open loop poles minus real part of a finite open loop zeros divided by p minus z. That is the formula for centroid. Next, here q value may be 0, 1, 2. It will go on increasing. Okay. Next, find the intersection points on root locus branches with an imaginary axis. So we can calculate the point at which the root locus branch that is intersect the imaginary axis and the value of k at that point by using a average criteria method, special case 2. If all elements of any row of the root array are 0, then the root locus branch intersect the imaginary axis and the vice versa. Identify the row in such a way that if we make the first element as 0, then the elements of the entire row are 0. Find the value of k for this combination. Substitute this k value in the auxiliary equation. You will get the intersection point of the root locus branch with the imaginary axis. We shall discuss the rule 5, how to find the value of k. We shall discuss in the problems. Okay, average criteria. First, they've asked in the question centroid asymptotes. Write this one. Okay, centroid, the formula and the asymptote. Okay, asymptotes give the direction of these root locus branches. You need to write down, and the formula you need to write. And the centroid, the intersection of point of asymptotes on the real axis is known as centroid. Then you write down the formula for that. Okay. Next, they have asked breakaway point. Okay, so here, if there exists a real access root locus branch between two open loop poles, then there will be a breakaway point in between these two open loop poles. When break-in point you will get if there exists a real access root locus branch between two open loop zeros, then there will be a break-in point in between these two open loop poles. Okay, open loop zeros. And break-in point exists only on the real axis root locus branches. So write K in terms of S from the characteristic equation 1 plus g of s h of s equals to 0. Differentiate K with respect to S. So make it equal to 0. Substitute these values of S in the above equation. So the value of S for which the K value is positive are the break points. So these things you need to write down for the breakaway explanation. Okay, breakaway points. Next is the angle of departure. Angle of departure and the angle of arrival. Angle of departure and the angle of arrival can be calculated as complex conjugate poles. Starting from the equation what they have given in the question, from that only we get the roots. From if we have the complex conjugate roots, then we should go with the angle of departure and the angle of arrival. It depends upon the poles and zeros. So the formula for the angle of departure phi d equals to 180 degree minus phi, and the formula for angle of arrival is phi a equals to 180 degree plus phi. Okay, where phi equals to what? Phi p minus phi z. Here angle of departure and the angle of arrival can be calculated complex conjugate open loop poles and complex conjugate open loop zeros. So angle of departure, when we will calculate, when we have only the only the poles. Okay, and the angle of arrival is calculated for it is calculated for open loop zeros. Okay, when we explain about the problem, you'll understand angle of departure and breakaway point, breaking point, and also centroid and asymptotes. Okay. Now you write down the just formula and the sentence of asymptote and formula for this sentence of centroid and the formula and breakaway point. Okay, breakaway point. You need to write down this breakaway point, this point. If the it is always breakaway point exists between the two poles, and write down the how you will calculate. And next you write down the angle of departure, the formulas for angle of departure, and what is the phi value. Phi is nothing but summation of phi p minus summation of phi z. Okay. For each they may give for 2 marks. Okay. So they have given the 4 centroid, asymptotes, and also breakaway points and angle of departure. So they have divided into 2 marks for each. Okay. So according to the marks, you write down. Next, we shall discuss with this question. Okay. A feedback control system has a open loop transfer function g of s h of s equals to k divided by s into s plus 4, s square plus 4s plus 20. So they have asked for 14 marks. Okay. Draw the root locus for k equals to 0 to infinity. Indicate all point on it. Okay. So this is the question. A feedback control system has an open loop transfer function g of s h of s equals to k divided by s into s plus 4 s square plus 4s plus 20. Plot the root locus for k equals to 0 to infinity. Indicate all the points on it. So what step 1? So s equals to 0, minus 4 and s equals to minus 2 plus or minus j4. These are the poles. Okay. So step 1, what you need to find out? P. So P equals to here 1. Okay. This one is 1, 2 and here from this 2. Okay. So overall how much you will get? 4. So Z equals to 0. Here nothing is there. So Z equals to 0. Okay. So n equals to p minus z. What you will get? 4 branches you will get. So 4 branches approaching to infinity. The starting points are like this: 0, minus 4, minus 2, plus or minus j4, and the terminating points is infinity. Okay. Section of real axis. So when you hold here, so here when you add 1 and the 2. Okay. This is s equals to 0, it is s equals to 0 and the minus 4. Okay. So 1, only 1 it is there. So root locus exists between from minus 4 to 0 and the breakaway point also exists between minus 4 and 0. Okay. Next, angle of asymptotes. So number of branches is 4. So you need to find out the theta 1 value, theta 2 value, theta 3 value, and theta 4 value. For theta 1, in order to calculate theta 1, you need to substitute the q as 0. Okay, q as 0. In order to substitute theta 2, here q plus, you need to substitute as 2. Sorry, you need to substitute as 1. Okay. You need to substitute as 1 for theta 2. Okay. Next, you need to substitute 2 for theta 3. Okay. And theta 4, q equals to 3. So that you will get the angle 45, 135, 225 and 315. P minus z value is 4. Next, you need to find out centroid. Summation of real part of open loop poles minus real part of open loop zeros divided by P minus Z. So real part of open loop poles are minus 4 and the here complex part is there. Okay. The complex part in that real part, this is the real part. Okay. This is the real part and this is the imaginary part. So you need to consider the real part. That too, it is 2 times. Okay. So minus 4, minus 2, minus 2. So what you will get? Minus 8 divided by 4, you will get the minus 2. Okay. Next, breakaway points. So breakaway points 1 plus g of s h of s equals to 0. So they have given that g of s value as k divided by s into s plus 4, s square plus 4s plus 20. And h of s value is 1. So take LCM, this will come to the numerator and this denominator, it will become 0. So s to the power 4 plus 8 s to the power 3 plus 36 s square plus 80 plus s 80s plus k equals to 0. K equals to take down to the right side. So this equation, all equation, it will become minus and this equation you differentiate with respect to yes. So what you'll get? Minus 4s cube minus 24 s square minus 72s minus 80 equals to 0. So what are the roots from this equation? What we get is s equals to minus 2 and s equals to minus 2 plus or minus j 2.45. So when you substitute s equals to minus 2, that is a k equals to, you are getting the 64. It is a valid breakaway point. So we have discussed already the breakaway point will be exist between 0 and minus 4. Now we got the value is minus 2. Okay. Next, step 6 is the intersection with the imaginary axis. For this, you need to consider the same equation what we have considered in step 5. Here, A0 is 1. Okay. And the A2 value is 36. And the here A4 value is K. Okay. A4 value is K. So 136 k you need to write. Next 8 into 36 minus 80 into 1 divided by 8. So you'll get the answer is 26. 8 into k minus 0 into 1 divided by k divided by 8 you will get. Okay, so you'll get the answer is k. 8 into k minus 0 divided by 8. So 8 will be get cancelled, you will get k. Next 26 into 80, 26 into 80 minus 8 into k divided by 26. Okay, from this equation, we need to find out the value of k. So what you get from that equation, 2080 minus 80k, 8k is equals to 0. 2080 equals to 8k, k equals to 2080 divided by 8. So what value you will get the k value? 260. A of s. Before that, what equation is there? A of s. 26 s square plus k equals to 0. So we know the value of k here, substitute, okay, 260. So s square equals to 260 divided minus 260 divided by 26, you will get 10 minus 10. So s equals to plus or minus j square root of 10. So s equals to plus or minus j 3.162. This is the intersection with the imaginary axis. Next, in the starting poles, we have the complex part. So we need to find out the angle of departure. Okay. So here the poles are like this. So 0 and the minus 4. 0, minus 4. And the next pole is what we got is minus 2 plus or minus j4. Okay. So minus 2 minus 2 plus or minus j4. Okay, minus 2 plus or minus j4, that is the root what we have. Now for this point, okay, so for this point, we are considering now only the minus 2 plus j4. Okay, so we join the poles. Okay, we join the poles. Now find out the angle for this. So find out the angle for this. Okay, from here to here, this is 5p1. Okay, so we don't know the value from here to here what it will be. Okay, so for example, the protector is like this, means if it is like this angle we don't know. For example, if we take this is 5p1, we don't know the value of 5p1. So 180 minus, it is 180 minus 5p1. If you do, you will get this value. Okay, so 180 degree minus, for example, this we shall take x. Okay, so 180 minus x if we do, so that you will come to know the value of 5p1. So this is the value of x from here to here. So this is nothing but, this distance is nothing but how much it is. So tan inverse of, okay, this angle we shall take as theta, tan inverse of, okay, opposite divided by adjacent. Opposite means how much it is, 4, and the adjacent means 2. Okay, so 4 divided by 2. Remember, 180 degree minus theta we are doing because we don't know the angle. Okay, from year to year how much it will be, 5p1. So 180 degree minus theta. Okay, we are doing the 180 degree minus theta. So in order to calculate theta, tan inverse of opposite divided by adjacent. Okay, so opposite value from here to here, how much it will be, plus j4, and from here to here it will be 2. So tan inverse of 4 divided by 2, how much you will get? 116.56, 180 minus tan inverse of 4 by 2, 116.56 degree. Next, similarly, 5p2, okay, 5p3, like this we need to find out. Next, 5p2, they have taken 5p2, this one, okay, so 5p2, 5p2, and this is the 5p3. Okay, so 5p2 is nothing but 90 degree. We can, if it is straight line, so yeah, this will be 90 degree. Okay. Next, for 5p3, tan inverse of 4 by 2. Okay, this angle, how much this angle will be there? Here also it will be same. Okay, when you consider the angle, 5p3, what we can write? Tan inverse of opposite divided by adjacent. So opposite is 4 and minus 4 minus 2, we can write down the difference is 2. Okay, so tan inverse of 4 divided by 2. So how much you will get? 63.43. Now add the overall 90, 63 and the 116.56. Okay, so when you add overall, you'll get 270. That is the summation of 5p. So 5z is 0 here because in this no zeros are there. So it will be, the value will be 0. Next, 5 equals to summation of 5p minus summation of 5z equals to, so this value is 0. So you'll get the 270 only. 5d equals to 180 degree minus 5. That is equals to 180 degree minus 270. You'll get the value is minus 90 degree. That is, till now we have done the angle of departure value minus 2 plus J4. Next, whatever you get that minus, for that answer, you need to write the opposite value for the minus 2 minus J4, because we have taken all intersection point. This coordinates is minus 2 plus J4. Okay, this coordinating points are minus 2 plus J4, right? This x-axis is minus 2 and the y-axis what it is there? J4. Okay, so that we have considered. So 5d equals to minus 90 we got. For opposite, while 5d equals to minus 2 minus J4 is 5d equals to plus 90. Okay, now we shall draw the root locus graph. So first what we need to mark? So first mark it the poles 0 and the 4 and minus 2, right? It is a complex part, minus 2, J4. Here also minus 2, minus J4, right? So we have done all, we have marked all the poles. Next, the centroid point. Okay, the centroid point, how much we got here? The centroid point is minus 2. Okay, so the centroid point is minus 2. So this is the, what we can write? This is nothing but centroid point. Okay, so this is a centroid point. Okay, next, after marking the centroid point, theta 1 value, and this is theta 2 angle. Okay, theta 1 angle, theta 2 angle, and theta 3. Okay, theta 4 we need to mark. After marking theta 1, theta 2, theta 3, what is the value of breakaway point? We shall see. Okay, what value we got the breakaway point? S equals to minus 2, then only it is valid breakaway point. So S equals to minus 2 we got. Okay, S equals to minus 2 only breakaway point. This is all breakaway point. Okay, and from here, next, angle of departure. So here one root is flowing like this and the another pole is flowing like this. The breakaway point is minus 2. Okay, so it one, this 4 will So this 4 will flow like this, okay, and the 0 will flow like this. And the next breakaway point is -2 plus j 2.4. That also you mark it. Okay. -2 plus j 2.4 -2 plus j 2.4. And the intersection with the imaginary axis, how much we got? J plus or minus j 3.162. Okay. So that also you mark first, okay, plus j 3.16 minus j 3.16. But what we got the value angle of departure we got the minus 90 degree for here -2 plus j4. Okay, this angle is for -2 plus j4. Okay. So first mark it the 90 degree. So you'll get the straight line. So this root also flowing like this. It is also flowing. So already two roots are flowing like this. One is 0 and the -4 is flowing like this. Okay. So it will flow towards infinity, and this will come and it will flow towards infinity. Okay, like this. So two poles is flowing towards infinity, and it is parallel to the asymptote line. And next, if this line, what we have done, okay, this will flow to the, towards the what? Towards infinity, towards infinity. And the next one, -2 plus some -2 minus j4. This root, what we have written at the starting, this will flow like this and it will flow to the infinity. Okay, this is the starting point. It will start from like this and it will flow towards infinity. Okay, this is the four poles is flowing. Starting point is 4 and 0, and the ending point is the infinity. Okay, here also -2 plus j4 is the starting point, and it will end towards what? It will end towards it will end at the infinity point. Okay, so you'll draw the angle of departure. That line you should intersect with the imaginary axis. Okay, you should intersect with the imaginary axis, because this should go to the infinity. Okay, because till here we cannot write the we cannot mark till here. Okay, it should join the intersection point and it should go to the infinity. So in order to where it should join, so that is what we have found out, intersection with the imaginary axis. So this point is moved to it will join at the minus j 3.16 and it will go towards the infinity. Here similarly, here also we cannot stop here itself. Okay, it will start from here and we cannot stay here. We cannot say it will stop here. Okay, it will join intersection point with the imaginary axis. It will join at the imaginary axis and it will reach to the infinity. Okay, the angle of asymptotes will be written till here. In next class, we shall discuss with the other problems.